Today I am going to present how to do the analysis of continuous beam by Kanis method when both hands are simply supported. Already you know in theory part that how to find out the final moment using the Kanis method. Like slope deflection method, here also you have to find out the final moment by considering the fixed end moment and the near end rotation moment and far end rotation moment. You know in the slope deflection method, what is near end rotation moment and what is far end rotation moment. So the near end rotation moment is your equal to 4EI theta by L and the far end is your 2EI theta by L. So similarly here also you have to take the 2 M dash AB. M dash AB is the near end rotation moment and M dash BA is the far end rotation moment. MFAB is the fixed end moment and the MAB is the final moment. So the final moment that you can find out, so by considering the fixed end moment and then twice of the near end rotation moment and once the far end rotation moment. MAB is equal to MFAB plus 2 M dash AB plus M dash BA. MAB is the final moment. Similarly, the moment MBA that also you can find out. MBA is equal to MFBA plus 2 M dash BA plus M dash AB. MFBA, the fixed end moment BA, and M dash BA, this is the twice the near end rotation moment and once the far end rotation moment. So using this formula, you can find out the final moment using the Kanis method. The final moment MAB and MBA can be determined by the superposition of the three moments, that is MAB is equal to MFAB plus 2 M dash AB plus M dash BA. Similarly, MBA is equal to MFBA plus 2 M dash BA plus M dash AB. The moments M dash AB and M dash BA are called the rotational contribution. So this is called the rotational moment. The final moment is equal to fixed end moment plus 2 into rotation contribution of near end plus rotation contribution of the far end. Then what is rotation moment and what is rotation factor? So the rotational moment that you can find out, M dash AB is equal to minus half KB divided by summation of KB into MFA plus summation of M dash BA. So here minus half into KB by summation of KB. So this is called the rotation factor. This is called the rotation factor. So the rotation factor that you can denote by UAB. So UAB is equal to minus half KB divided by summation of KB. So using this formula, you can find out the rotation moment. So the near end rotation moment that you can find out, M dash AB is equal to UAB into the fixed end moment of joint A plus sum of the far end rotational moment, that is summation of M dash BA. So the rotation factor UAB is equal to minus half KB divided by summation of KB. So using this formula, you can find out the rotation moment. After getting the rotational moment, then using this formula, you can find out the final moment. How you have to do the analysis of continuous beam? So these are the steps. First, you have to determine the fixed end moments. You have to assume the ends are fixed and you have to find out the fixed end moments. Then determine the relative stiffness of the members. Then you have to find out the relative stiffness of the members. Then determine the relative stiffness of the joints. Then you have to find out what is the relative stiffness of each joint, of each intermediate joints. Then you have to find out the rotation factors. After getting the relative stiffness of the members, then relative stiffness of the joints, then you can find out what is the rotation factors. Then after getting the rotation factor, then you can find out what is the rotation moments. Determine the rotation moments by iterative process. So the rotation moment that you can determine by iterative process. Then after getting the rotation moment, then you have to find out the final moment. Determine the final moments. Then after knowing the final moment, then you can draw the bending moment diagram. Then you can find out what is the reaction, shear force. Then you can also draw the shear force diagram. So how to find out the final moment, that is different for different method. So here by using Kanis method, you can find out the final moment by following these steps. So first you have to find out the piston moments, then you have to find out the relative stiffness of the members, then you have to find out relative stiffness of the joints, then you have to find out the rotation factors, then by iterative process you can find out the rotation moments, then after using this formula you can find out the final moment. So coming to one example, determine the end moments of the continuous beam shown in figure. The relative I values for each span are indicated along the member. E is constant. Here this is the continuous beam. End A and end D both are simply supported. Here the end A is hinged and end D is roller support. B and C is the intermediate support. The span length AB is given 4 meter and span length BC is given 8 meter and span length CD is given 6 meter, and the moment of inertia for span AB is I, and for span BC is 2I, and for span CD is 1.5 I. These are the moment of inertia given, and the load is given on the span AB, that is 40 kilonewton load at a distance 3 meter from the support A. Then on the span BC, there is having the uniform distributed load 10 kilonewton by meter. Then on the span CD, there is having one concentrated load at the midpoint of the span CD, that is 40 kilonewton. So how you have to do the analysis of this continuous beam when both ends are simply supported? When both ends are fixed, so that case you have to find out what is the piston moment simply. Then you have to find out the relative stiffness of the members. Then you have to find out the relative stiffness of the joints. Then you have to find out the rotation factor. Then by iterative process, you can find out the rotation moment. Here also you have to follow the same process, but here the ends are simply supported. The beam has hinge and roller support at A and D respectively. This is hinge support and this is roller support. The ends are fixed and their relative stiffness of span AB and CD are taken as 3/4 KB and 3/4 KCD respectively. So when the ends are simply supported, so for this corresponding span, you have to find out the relative stiffness 3/4 into I by L. 3/4 into I by L. So for span AB, you have to find out 3/4 I by L, and for span CD, you have to find out 3/4 I by L. But here I is given I, so 3/4 into I by 4. But in this case, 3/4 into 1.5 I by 6. Because for CD span, the moment of inertia is given 1.5 I. So here the relative stiffness for CD is your 3/4 into 1.5 I by 6. This is. The ends are fixed and the relative stiffness of span AB and CD are taken as 3/4 KB and 3/4 KCD respectively. Then what you have to do, because here this is simply supported, so you know at the simplest, you have to assume this is fixed and you have to make the moment here is your 0. You know the moment at the simply supported end is 0. The fixed end moments MFBA and MFCD are modified. So due to this simply supported end, so you have to find out what is the modified moment this side and this side, MFAB and MFBA, and here the moment will be modified to MFBA, that is modified to MFBA minus half into MFAB. So what is the piston moment here? So this moment, you know what is the piston moment here, MFAB. You know what is the piston moment here, MFBA. But you have to find out what is the modified moment here, MFBA. So MFBA is equal to MFBA minus half of MFAB. MFBA minus half of MFAB. So this is the modified moment. This is M dash FBA, modified moment. Here this end you can find out. So what is the moment, piston moment here, MFBA minus half of this piston moment. This side half of the piston moment. MFBA minus half of MFAB. Similarly, here also you can find out the modified piston moment, M dash FCD. M dash FCD, that you can find out MFCD minus half of MFDC. MFCD minus half of MFDC. This is the modified moment you can find out here and here. With this modification, the hinged or roller ends are assumed to be fixed, having zero end moments. So here the moment you have to take 0, and here the moment you have to take 0, and here you have to get the modified moment. M dash FBA is equal to MFBA minus half of MFAB. Similarly, here you have to find out the modified moment. Modified moment M dash FCD is equal to MFCD minus half of MFDC. So here you can find out the modified moment, and here you have to assume the moment is your 0. After modification, you have to take the moment at the end is your 0. First you have to find out the piston moments, because you have to assume all ends are fixed, and you have to find out what is the piston moments. MFAB, MFBA, MFBC, MFCB, MFCD, and MFDC. And here this is eccentrical loading. So what is the piston moment here? MFAB is equal to minus WAB square by L square. Minus WAB square by L square. So this is equal to minus 7.50 kilonewton meter. Similarly, MFBA is equal to plus WA square B by L square. 40 into 3 square into 1 by 4 square. 3 square 1 into 4 square. This is plus 22.50 kilonewton meter. Similarly, on the span BC, there is having the UDL 10 kilonewton by meter. So what is the moment MFBC and MFCB? Minus 10 into 8 square by 12. Minus 10 into 8 square by 12 minus 53.33 kilonewton meter. Then MFCB is equal to plus 10 into 8 square by 12 plus 53.33 kilonewton meter. Then MFCD, here having the concentrated load at the midpoint. So what is the piston moment, MFCD and MFDC? Minus WL by 8, and this side plus WL by 8, 40 into 6 by 8. MFCD is equal to minus 40 into 6 by 8 is equal to minus 30 kilonewton meter. MFDC is equal to plus 40 into 6 by 8 plus 30 kilonewton meter. These are the piston moments. Then you have to find out the modified moment. Then you have to find out the modified moment at the end BA and at the end CD, and you have to make here the moment is 0 and here the moment is your 0. After getting the modified moment here and here, then you have to take here the moment is 0 and here the moment is 0. Piston moments. The moments are adjusted to account for the hinged or roller support. This moment you can find out for the hinge or roller support at the end D. The adjusted moments are MFBA is equal to MFBA minus MFAB by 2, because you know MFBA is your 22.5 and MFAB is equal to minus 7.5. So MFBA minus MFAB by 2. MFBA, this is 22.5 minus MFAB by 2. So this is your equal to 26.25 kilonewton meter. Similarly, find out the modified moment this one MFCD. MFCD is equal to MFCD minus half of MFDC. MFCD is equal to MFCD minus half of MFDC. MFCD is equal to minus 30. This is minus 30 and MFDC plus 30 minus 30 minus 30 by 2 is equal to minus 45 kilonewton meter. So this is the modified moment MFBA and MFCD. Then you have to take at the end the moment is your 0, piston moment is your 0. After getting the modified moment, then you have to for simply supported end, then you have to take the moment at the end. Simply supported end is your 0. Piston moment at the simply supported end is 0. MFAB is 0 and MFDC is 0. Then find out the rotation factors. So for rotation factor, you have to find out what is the relative stiffness of the members. Then you have to find out the relative stiffness of the joints. Then using this formula, you can find out what is the rotation factors. So the rotation factor is equal to U is equal to minus half into KB divided by summation of KB. Rotation factor is equal to minus half into the relative stiffness of the member divided by the relative stiffness of the joint. So this is the relative stiffness of the members and this is the relative stiffness of the joints. So using this tabular form, you can find out what is the rotation factors. So here there are two joints B and C. This is one joint and this is another joint. So at joint B, so there are how many members meet? Two members, BA and BC. And at joint C, how many members meet? CB and CD. So here you take first take joint B and C. Then for joint B, there are two members BA and BC. And for joint C, there are two members CB and CD. Then write the relative stiffness of the members. So you know BA, what is the relative stiffness? 3 by 4 into I by L. 3 by 4 into I by 4. 3I by 16. Then what is the relative stiffness of the BC? For intermediate span, so you can find out the relative stiffness I by L. 2I by 8. If the end is simply supported, and for that span, you can find out 3 by 4 into I by L. And for all intermediate span, you can find out I by L. So here for intermediate span BC, so what is the relative stiffness? 2I by 8. And for this span, KCD is equal to 3 by 4 into 1.5 I by 6. So BC is equal to 2I by 8 is equal to I by 4. Then CB is equal to 2I by 8 is equal to I by 4. Then CD is equal to 3 by 4 into 1.5 I by 6 is equal to 3I by 16. This is the relative stiffness of the joints. How many members meet at joint B? B and BC. So this is the relative stiffness of the member BA. This is the relative stiffness of the member BC. So take the sum of these two relative stiffness 3I by 16 plus I by 4. So this is equal to 7I by 16. So this is the sum of the relative stiffness of joint B. Similarly at joint C, how many members meet? CB and CD. CB relative stiffness is I by 4 and CD relative stiffness is 3I by 16. So what is the relative stiffness of the joint C? KC is equal to KCB plus KCD. So this is KCB, this is KCB plus this is KCD. Then the sum is equal to 7I by 16. Then find out the rotation factor of the members. So find out a UBA. This is the rotation factor, you can denote by U. So for BA, UBA is equal to minus half KBA divided by summation of KB. KBA divided by summation of KB. So KBA is equal to 3I by 16 minus half into 3I by 16 divided by 7I by 16. So this is equal to minus 3 by 14. Similarly, find out UBC. UBC is equal to minus half KBC divided by summation of KB. UBC is equal to minus half, then KBC is equal to I by 4. Summation of KB is equal to 7I by 16. So minus half into I by 4 divided by 7I by 16. Then after simplifying, this is the value, minus 4 by 14. UBC is equal to minus 4 by 14 and UBA is equal to minus 3 by 14. And one thing you have to remember, at the joint, the sum of the rotation factor should be minus half. Always you have to check at each joint, the sum of the rotation factor, that should be minus half. So here you see UBA you got minus 3 by 14, UBC you got minus 4 by 14. So what is the sum of these two rotation factor? Minus 3 by 14 minus 4 by 14. So this is here equal to minus half. Similarly, find out UCB. UCB is equal to minus half KCB divided by KC. So this is the KC value. This is the sum of the relative stiffness at joint C, and this is the relative stiffness of the member CB. This is relative stiffness of the member CD, and this is relative stiffness of the joint C. So you can find out UCB is equal to minus half KCB divided by KC. Minus half into I by 4 divided by 7I by 16. So this is here equal to minus 4 by 14. Similarly, find out UCD. UCD is equal to minus half KCD divided by summation of KC. That is relative stiffness of the member CD divided by the relative stiffness of the joint C. So UCD is equal to minus half into 3I by 16 divided by 7I by 16. So this is here equal to minus 3 by 14. Here also at joint C also you can check. So the sum of the two rotation factor is here coming minus half or not. So here you are getting this is minus 4 by 14 minus 3 by 14. So the sum is here equal to minus half. Then after getting the rotation factor, then you can find out the rotation moment by iterative process. So first to find out the piston moment at joint, the sum of the piston moment at B is equal to MFB is equal to MFBA plus MFBC. Already you know MFBA and MFBC. You got MFBA, you know MFBA is equal to modified moment to 26.25. MFCD is equal to minus 45, MFAB 0, MFDC 0. And MFBC and MFBC, this is your remain same, MFBC and MFCB minus 53.33 and this is plus 53.33. Only this is changed, MFAB, MFBA, MFCD, MFDC. For modified moment, only the end span will be changed. So MFBA is your 96.25, MFCD minus 45, MFAB 0, MFDC 0. So first to find out the sum of the piston moment at B, MFB is equal to MFBA plus MFBC. So this is MF modified moment, MFBA, and this is MFBC. 26.25 minus 53.33 is equal to minus 27.08 kilonewton meter. Similarly, find out the sum of the piston moment at C, MFC is equal to MFCB plus MFCD. 53.33 minus 45 is equal to plus 8.33 kilonewton meter. Then find out the rotation moments using this type of tabular form. So here A, B, C, D. At the joint B, so you make one block, this type of block, and at the joint C, you make this type of block, rectangular block. Two rectangular block, then you join these corners, four corners. This is one rectangular block, and this is another rectangular block, and the corresponding corners you can join. This is how you make this type of rectangular block at the joint B and joint C. Just at the middle rectangular block, you write the piston moment. At the middle rectangular block, you write the piston moment of joint B and joint C. For joint B, write here, and for joint C, write here. And you know what is the rotation factor? BA, BC, already you got here. BA, rotation factor BA, rotation factor BC, then rotation factor CB, rotation factor CD. So just to write this rotation factor here, because this is A, B, C, D. So BA, this is, so the UBA right here in this box, and UBC right in this box, the rotation factor. Then UCB right in this box, and UCD right in this box. So inside rectangle, just write the rotation factor, and the middle rectangle, write the piston moment of the joint B. Then here you draw one line. This is one line, horizontal line, and at the end is your fixed. This is, and you know at the end the moment is your zero. You know the rotation moment is your zero. The moment is your, the piston moment is zero, because at the end modified moment here MFAB, MFDC is your zero, and MFBA is 26.25 and MFCD minus 45. Just write these moments above this line. So MFAB 0 and MFBA right here 26.25, then MFBC minus 53.33, then MFCB plus 53.33, then MFCD minus 45, and MFDC 0. Just above the horizontal line, just write the piston moments. So MFAB right here, MFBA right here, MFBC right here, MFCB right here, MFCD right here, MFDC right here. Then just below the line, find out the rotation moment in iterative process. Determination of rotation moments in tabular form. So first to find out this one. First to find out the rotational moment, M dash BA, then M dash BC. These two. First to go for the cycle 1 and find out what is the rotation moment. These are the cycle 1 rotation moment. This is M dash AB, and this one is your M dash BC. This is M dash CB, and this is M dash CD. And at the end, the rotation moment is your 0. First cycle, find out this rotation moment. I will find out this rotation moment. So first to go to joint B and find out what is the rotational moment M dash BA and M dash BC. Then you go to joint C and find out what is the near end rotational moment M dash CB and M dash CD. So first you go to joint B. At joint B, you know what is the sum of the piston moment at joint B. This is already you got minus 27.08. Sum of the piston moment at B is equal to minus 27.08. Then sum of the M dash AB, rotation moment of far end of members meeting at joint B. Then what you have to do? So how many members meet here? Two members, BA and BC. You have to find out the near end rotation moment, M dash BA and M dash BC. So how will you find out this near end rotation moment? M dash BA is equal to UBA into MFB plus summation of M dash AB. Sum of the far end rotation moment. You have to take the piston moment of the joint B plus sum of the far end rotation moment. How many members meeting at joint B? So you have to take, this is the at joint B, this is far end rotation moment, and this side this is the far end rotation moment. For first cycle, you don't know what is the far end rotation moment, so you have to assume, you are assuming this is fixed. Here the rotation moment is your 0, and this side you don't know what is the rotation moment, so this side you have to assume the rotation moment is your 0. So M dash CB you have to assume 0, and at the fixed here this is your 0, and you have to find out what is the near end rotation moment M dash BA and M dash BC. So M dash BA is equal to UBA into MFB plus summation of M dash AB, and M dash BC is equal to UBC MFB plus summation of M dash AB. Here you know M dash AB you have to assume 0, assume A is fixed, and M dash CB you have to assume 0. Initially you have to assume the far end rotation moment is equal to 0. M dash CB is equal to 0. Then you put here in this formula m dash ba is equal to minus what is the rotation factor uba, already you know. uba is equal to this one, uba this one, and ubc this one, and ucb this one, and ucd this one. uba minus 0.21 into what is the piston moment of the joint B, minus 27.08, minus 27.08 plus the far end rotational moment you have to assume 0. Then after simplification you get here m dash ba is equal to 5.68 kilonewton meter. Similarly find out m dash bc. Here you write 5.68 the rotational moment, 5.68 kilonewton meter. So just below this line you write here 5.68 kilonewton meter. Then find out m dash bc. So m dash bc is equal to ubc into mfb plus summation of m dash ab, the sum of the far end rotation moment. So here ubc is equal to 0.29 minus 0.29, this one ubc minus 0.29 into the piston moment of the joint B plus the far end rotation moment, you are assuming this is 0, 0 plus 0. So this is equal to plus 7.85 kilonewton meter. M dash BC is equal to plus 7.85 kilonewton meter. So here you put plus 7.85 kilonewton meter. So here you got the near end rotational moment of joint B, this side and this side. Then you got to joint C. Then find out this near end rotational moment. M dash CB and M dash CD. M dash CB is equal to UCB into MFC plus sum of M dash BC, far end rotational moment of this joint. So for this joint, which one is the far end rotational moment? This is far end rotational moment. When we are considering joint C, so which one is your far end rotational moment? This is far end rotational moment and this is far end rotational moment. But here, when you are considering joint C, so you have to take this side, the far end rotational moment is your 7.85, and this side you have to take the far end rotational moment 0, because already you know this moment, 7.85, and you have to take this side the moment is your 0, and you find out what is the near end rotational moment m dash CB and m dash CD. You have to find out minus this one and this one. So joint C, m dash CB is equal to UCB into MFC plus sum of m dash BC. So UCB is equal to minus 0.29 and MFC, that is the piston moment of joint C, 8.33 plus sum of m dash BC, far end rotational moment. So far end rotational moment, one side you are taking 7.85 and the other side fixed, this is 0. This is, you got already 7.85 and this side you have to take, this is 0 fixed. 7.85 plus 0, this is equal to minus 4.69 kilonewton meter. So here you put minus 4.69 kilonewton meter. Then find out this one, m dash CD. So m dash CD is equal to UCD into MFC plus sum of m dash BC. M dash CD is equal to UCD into MFC plus sum of m dash BC. So UCD you know this is minus 0.21 and MFC you know 8.33 and sum of the far end rotation moment. So sum of the far end rotation moment, one side your 7.85 and the other side is your assume fixed. So this is 0. 7.85 plus 0 is equal to minus 3.40 kilonewton meter. So here you put minus 3.40 kilonewton meter. Then your first cycle is over. So here you got m dash BA, m dash BC, m dash CB and m dash CD, and here you got the rotational moment for first cycle. Then you go for the second cycle and find out what is the rotational moment. Again you go to joint B and find out what is the near end rotational moment m dash BA and m dash BC. When you are getting the rotation moment, near end rotation moment in second cycle, so what you have to take, this side you have to take the rotational moment is your 0 because this is assuming fixed. But here this side you have to take the rotation moment, this one. In second cycle, you have to take the rotational moment, this one, because already you got this one. In first cycle, you got the rotational moment. So here you have to take, this is the rotational moment, the far end rotational moment of joint B. You have to take, this is the far end rotational moment of the joint B. Already you got in first cycle, this one. And this side is your 0. So you have to take second cycle, m dash B is equal to minus 0.21 minus 27.08 plus 0 minus 4.69. Already you got here minus 4.69, and this side is your 0. Is equal to 6.67 kilonewton meter. So the near end rotational moment you got, m dash B is equal to 6.67 kilonewton meter. So here you put 6.67 kilonewton meter. In second cycle, you put here 6.67 kilonewton meter. Similarly, find out m dash BC. M dash BC is equal to UBC into MFB plus sum of m dash AB. Sum of m dash AB. So UBC is equal to minus 0.29 and MFB is equal to minus 27.08 plus sum of the far end rotation moment. So this side is your 0, and this side you have to take what you got in the first cycle. First cycle you got minus 4.69. So this you have to take and find out m dash BC. This value you have to find out. For second cycle you have to find out this value. So m dash BC is equal to minus 0.29 minus 27.08 plus 0 minus 4.69 is equal to plus 9.21 kilonewton meter. So this is 9.21. You got, then find out m dash CB, then m dash CD. When we find out m dash CB, when we are considering joint C, so this is the far end rotation moment, and this side the far end rotation moment is your 0. So you have to take 9.21, and this side you have to take 0. And this is the piston moment of joint C is your 8.33, and this is the rotation factor UCB minus 0.29 and UCD minus 0.21. So find out m dash CB. M dash CB is equal to UCB into MFC plus sum of the m dash BC. So sum of m dash BC is your equal to 9.21 one side, and the other side is your 0. M dash CB is equal to minus 0.29, 8.33 plus 9.21 plus 0. This side you are taking 9.1 because already you got this one, and this side is your 0. 9.21 plus 0, this is your equal to minus 5.09 kilonewton meter. So here you put minus 5.09 kilonewton meter. You got this one minus 5.09 in second cycle, and find out this one m dash CD. M dash CD is equal to UCD into MFC, piston moment of joint C, plus sum of the far end rotation moment, sum of the far end rotation moment of joint C, that is sum of the m dash BC. M dash CD is equal to minus 0.21, 8.33 plus 9.21 plus 0. So this is equal to minus 3.68 kilonewton meter. So this is minus 3.68 kilonewton meter. You have to put here. So you got here for second cycle, what is the rotation moment. Again you go for third cycle and find out the rotation moment for joint B and joint C. M dash BA, M dash BC, M dash CB, and M dash CD. When you will get the rotational moment, near end rotational moment, m dash BA for third cycle. So what you have to take? So what is the value you got in the second cycle, the rotational moment of the far end, that you have to consider. So you have to consider here minus 5.09 one side, and other side you have to take 0. When you will find out the near end rotational moment for the third cycle, because already you know in second cycle minus 5.09 the far end rotation moment, and this side is your 0. Only you have to remember this one, because the far end rotation moment initially you have to assume 0, and after getting the rotation moment for first cycle, then you have to take that value far end rotation moment. So here for third cycle you have to take the rotational moment of the second cycle. Here this side minus 5.09, this side is 0. So find out m dash BA, third cycle. M dash BA is equal to minus 0.21 minus 27.08 plus 0 minus 5.09. This is minus 5.09. So find out what is the value. This value is 6.75 kilonewton meter. M dash BA is equal to 6.75 kilonewton meter. So here you put 6.75 kilonewton meter. Similarly, find out this one also. M dash BC is equal to UBC into piston moment of joint B plus sum of the far end rotation moment. This side is 0 and this side you have to take minus 5.09. M dash BC is equal to minus 0.29 minus 27.08 plus 0 minus 5.09. So this is equal to 9.33 kilonewton meter. So here you put 9.33 kilonewton meter. Then go to joint C and find out M dash CB and M dash CD. When you find out for M dash CB, so here you got 9.33 far end rotational moment. This side and this side is your 0. This side is 0. So you have to take 9.33 and this side 0. And find out M dash CB, near end rotational moment. This value find out. M dash CB is equal to minus 0.29, 8.33 plus 9.33 plus 0. So this is equal to minus 5.12 kilonewton meter. Put here minus 5.12 kilonewton meter. Then find out the M dash CD. So M dash CD is equal to UCD into MFC plus sum of the M dash BC. Here you have to take 9.33 this side 0, the far end rotation moment, and this is the piston moment 8.33, and this is the rotation factor. Let's find out M dash CB is equal to minus 0.29, 8.33, 9.33 plus 0 minus 5.12 kilonewton meter. So here you put minus 5.12 and this side M dash CD is equal to minus 0.21, 8.33 plus 9.33 plus 0 is equal to minus 3.71 kilonewton meter. This side minus 3.71 kilonewton meter. Now you got for the third cycle what is the near end rotation moment. So here you see this is 6.67, this is 6.75. To continue this iterative process till getting the similar values. In second and third cycle, this is the difference. Here 9.21, 9.33, and here these two difference is your 5.09, 5.12. Here this difference is 3.68 and 3.71. Again you go for another cycle, one more cycle, fourth cycle, and find out what is the rotation moment. Similarly, find out joint B and for joint C. So for joint B, M dash BA is equal to 6.76 kilonewton meter. This one 6.76 kilonewton meter, and for M dash BC 9.34 kilonewton meter. This is fourth cycle 9.34 kilonewton meter, and for joint C M dash CB minus 5.12 kilonewton meter. This is minus 5.12 kilonewton meter, and M dash CD and M dash CD is equal to minus 3.71 kilonewton meter. Minus 3.71 kilonewton meter. These are the values of rotation moment in fourth cycle. So then you just compare the third and fourth cycle rotation moment. So here 6.75, 6.76. This is almost equal. And here 9.33, 9.34 almost equal. This is minus 5.12, minus 5.12, same value. And here also minus 3.71. This is also minus 3.71. So almost you got the same value. So now you stop the iterative process and find out the final moment. The last value you have to consider are the rotation moment. So this value is not required. So only you have to take the last value is the actual rotation moment. That is M dash BA is your this one, M dash BC is your this one, M dash CB is this one, M dash CD is this one. Then after getting the rotation moment, then you can find out what is the final moment. So this is the final moment. So you know this is the formula. The final moment MBA is equal to MFBA plus twice M dash BA plus M dash AB. Already you got here the rotation moment. M dash AB is your 0. Initially you are taking M dash AB 0 and M dash BA you got 6.76 kilonewton meter and M dash BC you got 9.34 kilonewton meter and M dash CB you got minus 5.12 kilonewton meter and M dash CD you got minus 3.71 kilonewton meter and M dash DC is equal to 0. Then by considering this the rotation moment and the piston moment already you know, and you can find out what is the final moment. MBA is equal to MFBA plus twice M dash BA plus M dash AB. MFBA is equal to this one, modified piston moment 26.25 plus twice into 6.76 M dash BA plus M dash AB 0 is equal to plus 39.77 kilonewton meter. So this is MBA. Then find out MAB. MAB is equal to MFAB plus twice M dash AB plus M dash BA. You have to take this MAB as 0. Then MBC. MFBC plus twice M dash BC plus M dash CB. MFBC is your minus 53.33 and twice M dash BC 2 into 9.34 plus M dash CB minus 5.12 is equal to minus 39.77 kilonewton meter. This is MBC. Then MCB, MFCB plus twice M dash CB plus M dash BC. MCB is equal to 53.33 plus twice into minus 5.12 plus 9.34 is equal to plus 52.43 kilonewton meter. You have to put the value only, the rotation moment and the piston moment, then you can find out what is the final moment in this formula. Then MCD is equal to MFCD plus twice M dash CD plus M dash DC. MCD is equal to minus 45 plus 2 into minus 3.71 plus 0 is equal to minus 52.42 kilonewton meter. Then MDC is equal to MFDC plus twice M dash this one. So here this is 0. At the simply supported end, the moment is 0. Here 0 and here 0. You can also find out in this tabular form also. This is the piston moment. This is the piston moment, and twice near end, and here this is the twice near end, far end. This one near end, far end, twice near end, far end, twice near end, once far end. So this is the final moment. The same value you can find out in this way, or also you can find out in this type of tabular form. MBA is equal to plus 39.77 kilonewton meter, MAB 0, MBC minus 39.77 kilonewton meter, MBA, MBC. You have to check at the joint, the sum of the moments should be 0. This is 0 you got. Then MCB is equal to 52.43 kilonewton, then MCD is equal to minus 52.42 kilonewton meter. Or 43 you take. This is the sum of the moment is 0 and MDC is equal to 0. Then you have to give the direction of the moment. MAB 0, MBA you have to give, this is MBA 39.77, so clockwise. MBC, this is minus 39.77 anti-clockwise. Then MCB 52.43 clockwise. Then MCD minus 52.43, this is anti-clockwise. MDC is your 0. Then you can draw the bending moment diagram. So here at B the moment 39.77 here, and at C the moment is 52.43, and here the moment is 0, here the moment is 0. So join these lines. So this is the bending moment diagram due to the support moment. This is the bending moment diagram due to the support moment. Then what is the load is given on the span. So by considering this load, you have to draw the free bending moment diagram. So here this is 40 kilonewton, So here what is the free BMD? WAB by L. And what is the free BMD of this BC? This is WL square by 8. And what is the free BMD of this one? This is WL by 4. Having midpoint WL by 4. So in this way you can find out the moment for the free BMD. Then you have to plot the free bending moment diagram. The green color that indicates the free BMD, and the red color that is the bending moment diagram due to the support moments. Then after superposing these two diagrams, then the final bending moment diagram is this one, because this portion is cancel each other, and this portion is cancel each other, and this portion is cancel each other, and this is the positive, this is negative, positive, negative, positive. So this is the final bending moment diagram. This is. Then also you can draw the shear force diagram by taking individual span, and you have to find out what is the reaction. Then after getting the reaction, then you have to find out the shear force at different positions. Then after getting the shear force at different positions, you can draw the shear force diagram. Now all are clear?